Hello everyone, Namaskar, Raj Krishna this side, and today we are going to solve one more problem from partial differential equation. It's a nonlinear partial differential equation. As you can see, the power of p is 2, degree is more than 1, therefore it's nonlinear, and as it is mentioned, we will solve this by Chapit's method. So let's proceed. First of all, we have to write this in standard form. So let's write this as q minus 3p square equals to 0, because now it is of the form function of x, y, z, p, q equals to 0. So we can move ahead and write the Charpit's auxiliary equation or the Charpit's equation. So Charpit's auxiliary equations is something we'll be focusing on. And this is the most important part of the problem. So dx divided by something is there equals to dy divided by something is there, dz divided by something is there, dp divided by something is there, and finally dq divided by something is there. What is that something? Here we have minus, how we remember? The del f thing is present throughout. So del f will be there throughout, because for the sake of remembering, p has affinity towards x, so write here del p, and q has affinity towards y, so here del q. Fine. Now what about here? Just merge these two, but here you just multiply by things. So this will be multiplied by p, so minus p del f by del p, and this to be multiplied by q. In these two terms, del f by del z will be there. With that, in this p will be in multiplication, a plus sign. Here q will be in multiplication, plus sign. Again you will write here del f by del y, del f by del x. So these are the equations, important ones, right? Now let's find these things. Del f by del p. So this is the equation which we have in front of us. So if we find del f by del p, so q will be treated as constant. So del f by del p we are getting as minus 6p. Then if we find del f by del q, we will be getting 1. If we find del f by del x, that is 0. And same is true for del f by del y and del f by del z. All three are 0 because their terms are not present. So let's write this charpit auxiliary equation by putting this value. So dx divided by minus 6p, so 6p, dy divided by minus of 1, dz divided by uh, minus p time del f by del p. So 6p square minus q times this. So minus q simply, dp divided by, these two terms are 0, so you will get 0 only. dq divided by, again these two are 0, so you'll get 0 only. So this made our life a bit simpler, because if you equate this or this to any of this 3, so if I equate the fourth one with the first one, so dx by 6p equals to dp by 0, so I will get dp equals to 0, thereby giving me on integration p equals to some constant, let's say a. So there I get my first equation, p equals to a. Now I will put this p equals to a back in equation 1, putting p equals to a in equation number 1, which was q minus 3p square equals to 0, q minus 3p square equals to 0, q minus 3a square equals to 0, or your q is 3a square. Then we have this dz equals to this is appearing twice in this video. So then comes the famous equation, which is dz equals to small p dx plus small q dy. What is small p? That is a dx plus 3a square dy. So you get z equals to ax plus 3a square y. And of course the constant will obviously come, which is c here. So z equals to ax plus 3a square y is our final answer. Let's summarize what we did in this problem. So starting off, we wrote this in the form of function of xyz pq equals to 0. So we put everything to one side. Then we wrote the charpit's auxiliary equation, which is dx divided by minus del f by del p equals to dy divided by minus del f by del q equals to dz divided by minus p del f by del p minus q del f by del q, and so on as you have written. Find these things, del f by del p, del f by del x, del f by del y, and so on. Because these two were 0, so our life was simpler. Just p become equal to constant, which is a. Put that back in equation number 1, so you get q equals to 3a square, and then z dz equals to p dx plus q dy. There you integrate both sides, so you get z equals to ax plus 3a square y plus c as your final answer. That's it from my side. Thanks and have a nice day. For more such problems, you can visit my playlist on partial differential equations.